Now, the rest of this session is to do exactly the other thing, because as I've said many times before, as an intro to this portion of the session, that there's a limited value to just the presentation of correct method to solve something. Because I think, as some of you are finding out as you do the one-on-one meeting, that even when you've been working through the course honestly, as in you weren't trying to cut corners, you weren't skipping to the end of video and copying the formulas, you were actually watching the lecture videos, you're watching the homework help videos, simply watching them, you won't quite remember them well after some time. Really, the necessary part of learning is the struggle. That struggle is necessary part. Sometimes as you're struggling, you figure it out. You didn't need anybody's help. Like, that's one, that's great. That's, I think, ideal. But if you are struggling, even if you get stuck and you have to go to my homework help videos and watch the one presentation of how to do the problems. I think the fact that you struggled, that helps you remember, helps you kind of spot the areas where, as you watch the video, you realize, oh, that's how you do it. I didn't know that. So that's one way you might do. Now, if this was 2 years ago, my advice would have ended there. Struggle, suffer. I got some things to help you while you are suffering. And where we are now technologically is you don't have to be a rich person to have a tutor who will answer your questions, right away. Now, I did see some people using I always enable this, and I never get if people are using it or not. I did notice some people using it. So if this works for you, then great. It's something that the California community colleges have subscription to, so that's why there's a link. If the live tutor there is helpful, then great, use it, please. That's why the link is enabled there. I didn't disable it. Like, I disable a bunch of links. This is enabled so that you can use it. Now, sometimes maybe you're working at really weird time, or maybe there isn't. Maybe the net tutor thing wasn't all that helpful. I myself haven't used it, so I can't speak to the how helpful their tutors are. What I will tell you is, I think ChatGPT can be actually a helpful virtual tutor, and that's what I'd like to demonstrate for the remainder of the session today, unless there are questions from people who are here in real time. And I'd like to show you how you might use it as a virtual tutor. So let me turn into test student and go to the assignment that, let's say, I'm going to work through. This is the one that's due on Monday. So let me go into that assignment. I think oh wait, I must have unlocked through the things. I was going to complain that test student is my worst student and there were all the things that he hasn't done, but no. I might have unlocked those when I was working through the timed assessment for energy and momentum stuff. So let me bring up ChatGPT here, and we will work through this problem set using ChatGPT. Let me this time just to start with a proper prompt that I recommend that you always start your tutoring sessions with a ChatGPT with. Because if you don't, and if you simply give it the question, it'll probably answer the entire question for you. Then it's like my homework help video. It's no better than my homework help video, other than maybe, ChatGPT has the ability to use the actual numbers you got, but then that's actually worse, because then you learn even less from simply having the answer right away. So let me give this prompt to ChatGPT saying, hi, I'm back. I'm working through rotation problem set in my engineering physics class, and I need some help with some of the questions. And because I want learn/retain the information, if I'm simply given the answer, please don't give me the whole answer, right away. In fact, don't even give me the next step until I explicitly ask for it. I'll try to tell you what I've done so far, and I um and no comma, and to tell you where I think I'm stuck. Please just help me with where I'm stuck. So it's my message. So 45, 50 minutes. It's probably enough to work through 2 to 3 substantive questions. Let me find a few substantive questions. First, a few questions should be relatively simple. Although maybe um, this is not really a substantive question, but let me see how what kind of help ChatGPT gives me. So this is a rotational kinematics question. And if you look at the lecture, we basically didn't cover rotational kinematics in depth because my whole point is use an analogy. We spent some amount of time doing translational kinematics, and everything we did there kind of transfers over. So let me pretend that I missed all that and just complain to ChatGPT. So this is the first question, and looking back at the lecture, I think we just skipped rotational kinematics. So I feel really lost. Can you help? I won't mention that there's supposed to be a connection to translational kinematics. ChatGPT might actually bring it up. I'm interested in seeing if it'll kind of do that as a default advice. That's generally helpful. Oh yeah, yeah, it's reminding you of linear kinematics. Yeah, and that exactly applies to the rotational kinematics. That's the advice. So let me actually try to work through. I guess making mistakes on this might be too unrealistic, maybe. Um, oh, I can make a. Can I make a mistake on B? Maybe not. I don't know. So let's say I'm following this advice. So I'm looking at, okay, omega is equal to omega naught plus alpha t. So omega, wait, that's not what I'm using, sorry. Theta final. I'm using the first equation. So I say theta final is equal to theta initial reading through. I don't think there was an initial position, so 0 plus. Oh, I think I might be able to make this mistake because it's possible the answer here will go above 2 pi, and if I enter above 2 pi, they'll probably say it's wrong, and I can pretend that I missed that portion of the question text. Omega naught starts from rest, so that means omega naught is 0. So 0 times t plus 1/2 alpha t squared, so 1/2. This I'll say is alpha, so 6 radians per second squared. And because I'm pretending I'm a struggling student, I'm gonna ignore the units. Please don't ignore the units. It's one of the things that actually helps you the higher levels go. Dimensional analysis is a really powerful problem solving technique. So 10, but I'm gonna pretend that I'm struggling and hence forgetting about units. I can probably actually just do this calculation in my head. It's so this is 300 radians, seconds having canceled out. So I might put in 300 radians here. Don't know why the question says between 0 and 2 pi. That seems, I don't know. I would actually prefer 300 radians as an answer, because that's typically what you do. But yeah, but it might be a matter of a programming thing. I don't know if I program this in. Someone else might have. So okay, I did, but it says it's wrong. And ChatGPT will probably spot the question instruction about between 0 and 2 pi and tell me to figure out subtract some number of 2 pi's. So if you divide the 300 by 2 pi, then you should be able to find the integral number of 2 pi's that fit into it, subtract it off, and then get an answer. In fact, you know what? I made two mistakes. So this actually gives an initial angular position. That's minus pi over 2. Yeah, 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 yeah. So identify is theta initial minus pi over 2. Oh, I think that's why the question said this, because there's that ambiguity, that initial position, it could have been expressed as like 3 pi over 2. Yeah. So making you do this makes sure the final answer, there's one unique final answer that makes the automatic grading a little easier. So that must be why, because of that ambiguity. Minus pi over 2. So I think I actually need a calculator for the rest, because I can't divide it by 2 pi in my head. So 300 minus pi over 2 is that. I'm going to divide it by 2 pi. Actually, let me store that into memory first, and then divide it by 2 pi. 2 times pi. Then, so 47 is the integral number of the 2 pi's that fit into it. So 2 modulo 2 pi, I do memory recall, minus 47 times 2 pi. That's the modulo 2 pi operation, basically. So 3.12. Now, if you're not sure how to do modulo 2 pi, ask ChatGPT. That's really the benefit of an interactive system like a ChatGPT. There are things that sometimes, things that your tech instructor takes for granted, that you even know what modulo operation is, and it's the kind of things that sometimes you would have learned it in your prerequisite math classes, but depending on your math instructor, maybe you didn't learn it, and those kind of gaps in knowledge, which because unless you ask me, I'm just doing my best to try to guess where those gaps might be. Whatever I missed, you ask ChatGPT directly and it'll answer. So let me so I'll paste this in and I'll claim that I got this by trial and answer, and ask you to clarify what modulo means. Okay, I got the right answer, but it took so many tries, like 50 attempts. I don't think I understand what modulo means. Can you explain? And it'll probably describe some sort of procedure you can go through. Um, angle modulo 2 pi means recognizing equivalent to that's k being the integer number. So return physical duration angle standard range, keep subtracting 2 pi until oh that sounds like what I did, subtracting 2 pi one at a time. Is there a faster method? Sometimes you have to ask it to. Sometimes you have to interact. I've used the ChatGPT for coding before, and if the first version it gave me was not all that robust, then I asked it for more robust version. It gave me a version of infinite scrolling JavaScript that actually worked fine. Mathematical terms, So this is actually what I did. I took the angle, divided by 2 pi, and I took the floor, meaning the integer, that I just did it by eyeballing it. And then that's what I multiplied 2 pi to 2 and then subtracted. Yeah, that's the procedure. And you can program this into like most programs. Most quantitative software have like a floor function. It's kind of thing that exists in NumPy, Mathematica, MATLAB. Just to find the function name for it. So I think that's good for this question. Let me find maybe 2 more substantive questions that I can ask ChatGPT about. This question, by the way, I think I put it on this set mainly as a way to have you review, because this doesn't actually deal with the rotation. I could have asked this question way back when we were doing uniform circular motion and forces. Like, there's nothing new here that comes in the recent chapter. I can. Oh no. So there are problems that will require you to use conservation of angular momentum, and in those situations, you will find that kinetic energy is not conserved. That's not this one, because in this question, they gave you the kinetic energy and gave you the rotational inertia, and all you have to do is solve for omega. Although, I can do that and then get it'll say it's wrong, and I can ask a ChatGPT about that. So let me do that. So I can say, all right, I've studied, I'm a good student, I've done all this. I know rotational kinetic energy is 1/2 I omega squared. I see that this is my kinetic energy. This is my I. I'm being as for rotational rate, omega. So I solve this for omega. Omega is equal to square root of 2 times kinetic energy rotation divided by I. And I get a number. Let me get a number. So 2 times 112 joule. I look at the unit to make sure it's basic SI units. Divided by 9 kilogram times meter squared. Basic SI unit of rotation inertia. Get that. Take the square root. 4.99. 4.99. Or I guess you could go as far as 4.99 inverse a second. If you are paying attention to units, like write out what a joule is. Joule is kilogram times meter squared per second squared. Then you divide, So you do all that, you put in the number, you feel confident, and it'll say it's wrong. And, this is really the place where I think the generative AI is actually superior to just the homework help video. I do think I mentioned this in homework help video, what to watch out for, but maybe you missed that little bit where I say that you have to divide out 2 pi. So, generative AI can look at your work, oftentimes tell you exactly what you did wrong. I've had cases where it didn't actually specifically comment on my work. That might happen, then, work through it. Don't be difficult, like I am sometimes on purpose. But like in this case, I can say, oh, I thought I got this question and did everything right, but the answers wrong. Why? And it'll point out that the answer I got is radians per second, and I have to convert it to revolutions per second. And I'm putting scale quotes because this is one thing that you have to watch out for in rotation angles. We don't have any actual SI unit of angle. Like degrees is just an arbitrary thing that I try to avoid using. Radian is a proper SI unit, but it's not a real unit. It, dimensional analysis, it won't pop up. So, and revolution is same thing. You're just counting number of cycles. So you have to do this conversion, and it's the kind of thing. Even if you took the caution to do dimensional analysis, you will miss it unless you remember that the one revolution is 2 pi radians, and you just have to remember to do that. So yeah. So I'll say thank you and move on. Oh, that's annoying. Thank you. I got it. And properly, I probably should have done this calculation myself rather than copying what ChatGPT did. Yeah. All right. Let's move on to the next question. Yeah. This is a common mistake, and that's why you should also read the question carefully to see if it's asking for answer in radians per second or revolutions per second. I'll almost never ask for degrees per second because that's just annoying. I think radians per second makes sense if you want to make the formulas simple. Revolutions per second makes sense if you want to connect it to more intuitive quantities, like your engine RPM, revolutions per minute. So in that context, the revolutions can be helpful. But this is you're supposed to do this by direct integration, and I have lecture videos explaining it. So I think that's what I would recommend that you do. ChatGPT can't draw drawings, so I don't know if asking ChatGPT about how to set this up, other than giving you expressions for integrand, if it'll be better than lecture video. So I'm gonna skip it for this session, and let me find that question involving angular momentum. Oh, I pushed off the cross product lecture to the optional video, so I can imagine a student who's stuck. Because I did include the cross product by component into the required lecture video, but I don't know if that's all that helpful for this. So let me just imagine that I'm a, again, good student who has only watched the required lecture video. And so in the required lecture video portion, there's a very short couple minutes portion of the video where I do say torque comes from R cross F. And, to cover this cross product, I might say R cross F is the determinant of this 3 by 3 matrix. X hat, Y hat, Z hat, Rx, Ry, Rg, Fx, Fy, Fg. And this is all the stuff that's in the required portion of the lecture videos. And I don't think this actually helps you answer it, because it's asking for the force, and that's the challenging part. If it had asked you for, if it asked you for the torque, then yeah, you just apply this and you get it that way. But I think to find the direction of force, really knowing the right hand rule, there's no substitute for it. You should know the right hand rule. So x-axis of length. So this would be my R in order to produce a torque. So this would be my torque. And I think I can get the magnitude. So I can get, torque. So So the absolute value of torque is RF sine theta. And I think here it's all set up so that this will be just to 1. I can set up 90-degree angle. So for the force, I can say F is torque divided by R. So 15 divided by 2, even simple enough to do in your head, 7.5. And then the direction would be where I get stuck. Maybe I say this because I don't get that they're supposed to be perpendicular. Yeah, so I think so let me write this much. So along the x-axis, all that stuff. So that means r as a vector is the 2 meter x hat. I think you might even get that. So let's say you are here, where you've done everything that's utilizing things that were in the required portion of lecture video, but I just didn't have enough amount of time to put in the right hand rule demonstration. So you're missing the direction part. Does it hint to say about right hand rule? Maybe, yeah. So I'm frustrated, and I vented to ChatGPT. I for this question, I wrote down everything in the lecture, even the bits that looked complicated. But the professor didn't lecture on anything that would help answer this question. That guy. Now, there wasn't a question here, but ChatGPT is, I think, intuitive enough to infer the question from what I missed and probably tell me about the right-hand rule. It can't draw the drawing of right-hand rule, but it might give me the description of right-hand rule, or maybe even give me the answer right away. We'll see. Good starting point. Yeah, I already wrote that. I already did that. It's not figuring out what I've already done. That's frustrating. Oh, that's interesting. Is that possible to do that? I mean, I'm used to doing the geometric right-hand rule. This does seem like a long way, but this might be a way that I can defend myself that I've given you everything you needed. So let's just try following that. So if you are following what I did in the lecture, then you are doing this. So for this, to do the cross product, you imagine just copy over these two columns again, x hat 2 fx, y hat 0 fy. So you're gonna get 6 terms. You get these terms are gonna be coming with a positive sign, the ones going diagonally this way. Now I'm recognizing there are some terms, these zeros will vanish some terms. So this will go away, this will go away. So I only have to worry about R cross F is equal to the last one, G hat times 2 times Fy. And then now I have to look at the diagonals going left hand down. These are going to come with a minus sign. So this term, 0, don't have to worry about it. This term, 0, don't have to worry about it. And this term, y hat, that way. Okay. So let me write that up. Minus y hat times 2 times fg. And this should equal to the torque given, which is 15 g hat. And I think that actually rules out something. So whatever component of force, the G component of force you have, it's only going to give you a torque in the y hat direction. So doesn't help. You probably just want to set this equal to 0. So you can match G hat with a G hat here, and Fy is equal to 7.5. Yeah, that would work. So what that means is in order to get torque in the G hat direction, the force component you need is not the G hat component of force, it's the Y component of force. But let's say, imagine that I didn't realize this and just still got confused. I think, hey, I did a cross product and I got, G hat is what I need. That was my answer. Why is it still wrong? Let's imagine that I didn't figure that out. So I'm gonna say, okay, I did a cross product and it says I need a G hat, but the system said that answer was wrong. And I'm hoping ChatGPT will point out that in the expression, what matters is that you have the y component of f, not the unit vector portion. It's the y component of force f that should guide you to say that this should be y. Erase this bit so that it's not getting in the way. Won't produce. That's a long answer. Yeah, so again, sometimes it doesn't. Well, it's not looking at my work, but I think it's reproducing some of this. And as you are reading through it, you might realize, oh, yeah, force. Yeah, Fy. Oh, yeah, Fy. So that means force must be purely in the y direction. Yeah, good. Yeah. Ah, I got it. Thank you. You are much. I don't expect ChatGPT to defend me. It probably won't, because why defend the competition? Uh, But if anybody claims that in my required lecture video that I didn't include all the necessary material, this is my defense. You can actually answer this by using the cross product by components. But I would have done it using the right hand rule. And it's worth learning the right hand rule. The only reason I thought, it doesn't defend me. The only reason I thought we could basically skip the right hand rule in the required portion of the class is you just need it for one small part. You can get through most of physics 4A without needing it. When you take physics 4B, when you get to magnetism, that's where you actually have to learn right-hand rule really thoroughly. So it's coming up. So this semester, those who are interested, hey, you can watch that optional 2-hour lecture video that I'm telling you can skip. And I'm glad to see that, yeah, for someone who skipped it, it's still possible to answer these homework questions. Because for a minute, I thought, oh, I forgot about this question. I was thinking about a different question where you just had to do the cross product. So let's see. This I feel you can do it with the conservation of energy. There's a way you can do this using conservation of energy and make a mistake. We got 20. Let me maybe come back to this if we have enough time remaining at the end. What I want to do first is question like this one. I can mistakenly use conservation of energy to do it. And you should be using conservation of angular momentum, because this setup is a setup that it doesn't actually conserve energy. And the explanation, let me see if ChatGPT will explain. So I will use conservation of energy to answer, get a wrong answer. I'll even correctly account. Oh, actually here you don't have to account for the 2 pi. If you keep your angular velocity in units of RPM, it'll just work out. So let me say I'm using conservation of energy. I say, all right, my uh, total energy 1 is equal to total energy 2. And I say, oh, no potential energy. Everything is rotational kinetic energy. So, so I guess I should write out the all four terms. So it's going to be 1/2 rotational inertia of the merry-go-round times um, it's the one angular velocity squared. So let me call this omega 1 squared plus 1/2, and then I'll number the children. 1, 2, 3. Are they all at? Um, yeah, they are all riding on the edge. So actually, I can simplify it a little bit this way. I can say the the so rotational inertias of the children, I can write it as m1 plus m2 plus m3 times r squared. For combined rotational inertia of the children at the beginning, omega 1 squared, and say that's equal to the merry-go-round part doesn't change, 1/2 I m omega 2 squared plus, and then this is the mass of the second child, so 1/2 m1 plus m3 uh, times r squared omega 2 squared. I look up the rotational inertia of merry-go-round modeled as a disk. It should be its mass, capital M, times r squared divided by 2. That's the difference between disk and a ring. And in the interest of time, I'm gonna do the algebra for solving for omega 2 mostly in my head. It's gonna be omega 2. I'll cancel out something so it's a little bit easier to do this in my head. Omega 2 is going to be equal to omega 1 times square root of this factor, which is actually I can factor out r. So let me factor out r. Omega 1 times, actually r will cancel out, I think. R will cancel out of the entire thing. So yeah. So square root of big M over 2 plus all of this, m1 plus m2 plus m3 divided by big M over 2 plus m1 plus m3. And r squares would have canceled out, and if you want to double check my algebra, you can write it down. Make sure I didn't make a mistake. Oh wait, I didn't make a mistake. Yeah, make sure I didn't make a mistake. Omega 2 should be higher, I think, in either way. So yeah, so let's say I did all this and I'm plugging in numbers, and it'll say it's wrong because again, I'm making mistake from the very beginning, shouldn't be using conservation of energy. So I plug in the numbers, 24 RPM times, I need to start outside, way outside the parenthesis for square root later, and then inside the parenthesis for the numerator, and so 100 divided by 2 plus 22 plus 28 plus 33 inside the parenthesis closed, divide by the denominator parenthesis, 100 divided by 2 plus 22 plus skip 28 plus 33. Close the denominator parenthesis, close the big outside the parenthesis, and then take a square root. Is equal to 27.01 RPM. And you should say it's wrong, unless it's too close to the correct answer. You should say it's wrong. Hopefully it says it's wrong. Yeah. Then let's ask ChatGPT, what did I do wrong? I used the conservation of energy to do this question. What it says it's wrong? Is it because of the friction? Static friction in the problem or something? I don't know. Just some nonsense question to throw off ChatGPT. It should just tell me that the angular momentum is conserved. I'm hoping it'll explain why angular momentum is conserved. And as a bonus point, yeah, I would like it to explain through what mechanism energy changes. So yeah, angular momentum, yeah, that's what you use. Yeah, so if you're using angular momentum, I think basically the difference will be you get rid of the square root. Then I think going through angular momentum approach will give you the same answer, just without the square root. So let me just do that shortcut. Yeah, but if you want to make sure that I didn't make a mistake, just redo it from the beginning using angular momentum and see if that amounts to getting rid of square root. And let's did I? Yeah. Oh, I haven't been closing my calculators. Can I? I can't just edit it. I think. Yeah, this is why I normally prefer Wolfram Alpha. So, but I'll just do it from the scratch. 24 times the numerator. So 50 kilogram plus 22 plus 20 plus 33 divided by the denominator. 50 plus 22 plus 33. So 30.4. It should say it's correct. So maybe I'm confused because it's even higher. So let me ask ChatGPT for an explanation. I'm just trying to exclude the conservation energy part. Okay, they gave me the correct answer, but I still don't understand. If energy isn't conserved, shouldn't it be slower speed? I think with this higher speed, actually the final energy will be greater, and that doesn't make sense to me. And it does take a relatively careful consideration. You basically have to imagine moving this child and having to do work against the centrifugal force, or the kind of force you are pushing is the centripetal force, which is non-zero, that does positive work. Yeah, yeah. Increase it. Yeah, implies the actual no contradiction. Yeah, the child does, or whatever is moving the child inward does work. The force by which that is wrong. I mean, effectively produce a torque through. Yes, is there a torque? There. I don't think there necessarily is a tangential component. Um, I don't know. This is where I like using the shortcut. I mean, it does speed up, and I don't know. So the place where I would find the positive work being done is here. So if this is merry-go-round and spinning, and you imagine a child who's moving inward, and when this is spinning, the force so if it's at rest, then this force that's moving the child inward, it can approach zero. So you can do infinitesimally small amount of work and move child's position. That's possible. But the moment we say the whole thing is spinning, this force, it has to be greater than or equal to the centripetal force necessary to just keep it at the same radius. So it's m omega squared times r. It has to have that minimum force. So with however much radial displacement, you'll be doing non-zero work that way. I don't know if this is right. or this part effectively produces a torque. Although, I guess as an explanation of what gets the angular momentum of the child is decreasing, and that's due to a torque. So it's possible there must be a tangential component. So that might be actually right. Yeah. Rotational motion can be very unintuitive. That's why when in the optional lectures, when you see me going over pre-session, I use the shortcuts of that's actually how the formalism of dealing with the rigid body motion is helpful. If you try to um, immerse yourself in all the internal forces, it gets super confusing. So I'm gonna skip the part that I get confused by and say just accept the answer that ChatGPT gave. How does it work? That is the important part. There is a non-zero force associated with a displacement that's not perpendicular to the directional force. That part is yeah. Uh, sure, if I understood it. Thanks. So I think we might have enough time to do that rolling question wrong, and let's see if ChatGPT will correctly spot the right thing to do. So I'm gonna go to the was it question 7? Yeah. So I'll do this question wrong. I mean, conceptually it's right. So you can imagine that you treat this motion as a purely rotation to simplify it, to make it easier to deal with. So you can say yeah, you can say, all right, I got this bowling ball thing that's rolling, and I remember looking up solid sphere before. It should be 3/5 mr squared, and hopefully, if it's wrong, ChatGPT will tell me that's why my answer is wrong. In addition to the other reason that I'm gonna make. So this is my snapshot 1, and at the top, let's say the ball is rolling here, and I'll say treat as pure rotation about contact. That way I don't have to worry about translational motion. And again, conceptually, that can be a valid way of dealing with this. So you have omega initial, which I would work out. So this being V initial, the omega initial is V initial divided by the radius of the rolling ball, which I think will cancel out of the expressions, and I'll be working out for this final angular angular velocity. So I'll say conservation. Change color. Conservation of energy. This time, conservation of energy is right. And even the approach that I'm using, pure rotation, can be right, just with sufficient care. So I'll say 1/2 I omega initial squared is equal to the final gravitational potential energy, mgh, plus 1/2 I omega final squared. Solve for omega final is equal to, so masses will cancel out. And yeah, so I think I gotta write out some stuff. So square root of multiplying through by 2 gave me 2gh, and I'm gonna plug in I and say it's sorry, I need to start. So there will be minus 2gh divided by r, I think. Or let me keep going. Yeah. So the rotational inertia 3/5 times, and m canceled out. There's r squared up. times the omega initial squared. This is, I think, what I divided by this side. So 3/5 r squared. M already got canceled out. Yeah. So through that, the first term becomes simple. That's, I think, what I was expecting. Omega initial squared minus, and all the other considerations are on this. So 2gh, that's going to be 10 times g times h divided by 3r squared. But the fact that I don't know the R is fine, because they're not asking for omega final, they're asking for V final. So from here, I can say V final is equal to R times omega final. So that'll give me, under the square root, this will just become V initial squared minus, and R squared here will cancel out. I get 10 third GH. And I calculated all out. Let's get a numerical value to plug in. And again, it'll be wrong. I'm deliberately making a mistake. If you spotted a mistake, congratulations. Good job. I've been very careful not to blurt out what's going to be causing that mistake for me. 0.9. Okay, that's the whole thing. Oh, wait. Did I make another mistake? Oh, I think I forgot to divide by. Wait, no, R cancelled. It's 4.3. 4.3 squared is 18.49. So is it 2gh divided by so that number is too small. Oh, so I think the mistake I am making, it might be the cause of that. So this and divide by 3 times 9.8 times 0.9. Yeah, that is bigger than. Okay, so so let's imagine that I didn't spot that, and we just say 4.3 squared minus, then divide by 3 times 9.8 times 0.9 is equal to a negative value, and let's say I missed that and just took square root. Oh, and it says invalid input. Or I do, okay, maybe the minus sign is just some weird sign error. I do 10.91. So I say 3.30 meter per second. And it says it's wrong. And I ask ChatGPT. And I guess I'll explain some of the errors that I saw. I used the conservation of energy to do this question. And I did run into some issue when I got a negative number for the PHYS squared minus the term for gravitational potential energy. But I entered the value I get when I take square root of absolute value of the, and it says it's wrong. So as ChatGPT looks at my answer, I'll tell you what explanation I'm hoping for is. it should tell me that my rotational inertia is wrong. Not because I misremembered it. I'm pretty sure I remembered it correctly, 3/5. I need to use parallel axis theorem to correctly calculate rotation inertia about this point. So it's not 3/5 mr squared, it's 8/5 mr squared. And that's why actually I'm getting that issue, because this I that I'm dividing by should be a bigger number. So that should be turning this gravitational potential term smaller, small enough that, this difference doesn't become negative. That's what it should tell me. Let's see if, it infers all that from the work I've attached. I'd be impressed if it does. But, I think this is a pretty common mistake students make. So, I mean, let me see if, here it's doing the, so I'll say, but I didn't do that. I accounted for the rotation. In fact, to make the problem simple, I used the contact point as the point of rotation. So that I don't have to deal with the translational motion. I'm sure all this is fine. The professor lectured on this week. Blame me. And what I should have explained is, when you're doing that, make sure you're using correct rotation inertia. It's possible that, but is it giving you correct? I mean, this might get you to start thinking maybe, or give up on this approach and do the. Oh yeah. Yeah, good. So it didn't infer from my attached work that was my approach. But once you told the approach you were doing, then it knows about the common mistakes. These mistakes that I'm imagining my hypothetical test student making. I'm imagining it because it's a common mistake. So with that, so this should be 8/5. So that's 10 divided by 8. I think that should probably make it right. Let's try that. And just so we are not ending the session on just incorrect answers. So 4.3 squared minus 10 divided by 8 times 9.8 times 0.9. Now it's a positive number. Take the square root, 2.73. 2.73. Okay, why is that still wrong? I might have done it too quickly. 8/5. Is this 2/5? Let's see. This ChatGPT give me a Oh, it's 2/5. I did misremember it. Oh, you know what? I think what I'm confusing it with the rotational inertia of the hollow sphere is, I think, 1/3 mr squared. I think that's where I keep thinking of this 3 from. This is not the first time I've made this mistake, I tell you. So with that correction for 2, so that means what's 3 here? So this plus 5/5, this should be 7. So that should be 7. Let's correct it and do it correctly. Okay, 4.3 squared minus 10 divided by 7 times 9.8 times 0.9 square root of 10, 2.43. All right, yeah, good. All right, I got it. It also looks like I misremembered the solid sphere rotational inertia formula about its center. You gave me the fifth. I had 3/5. All right, I think that's all the time we have. A little bit over. Thank you so much to those of you who are joining here in real time, and those who may be joining back. Yeah, that's 2/3. All right. Um, really, at some point, I really shouldn't have been relying on my memory. So, the main thing, you are not required to memorize these rotation inertias. Main thing that you are required to do is that you know where to look it up. So, in the context of this class, that's in the correct chapter 10. I think section, I want to say 10.4 or 10.5, maybe 10.4. So just to know where you can look up your rotational inertias from, in section 10.4, then that's all that's required. You don't have to have it memorized. And when you are doing work as engineer, I'm sure there's like a table of stuff that you can look up. So that's what you require. It's okay. Thank you so much for joining. I'll say goodbye to people joining by recorded the video, by which I'm gonna stop the recording, and I'll stay online briefly in case there are any questions from my real-time person. So bye to people joining by recorded the video.